It just has a slightly different derivation. The function is different. Alright, so we know what T0 is, do we? Do we know what T0 is? Yes. That's this right here. This is T0 is what we should be calling it. I just don't know how to label anything apparently. So when it says that it's giving you a torque of a harmonic torque of that magnitude, then that's your T0, because your T is not constant, but in this case, it is your maximum. It's the unit that everything is based on. Okay, so with that, the damping. Oh yeah, this is the damping that's given. Here's the damping, the critical damping. We calculated the critical damping. So with these two, that one and this one, we can say that zeta equals CT over C critical. Okay. So just put this one over that one. We get a number for that, which should be 0.336. Alright, you plug this one back in, plug in T0, and you know what your amplitude is. So what this is going to do is that it's going to give you, the amplitude here is, because it's in a torsional setting, the amplitude is not going to be a distance, but a degree measurement. Where is my mouse? There it is. Yeah. So this right here is going to give you something in terms of degrees. Okay. You actually already know what that's going to be because it's given you the amplitude already is 2 degrees equals T0 divided by excuse me KT 19.93 excuse me. I ate an oatmeal cookie earlier and it's the oatmeal is attacking the inside of my esophagus. Or no, keep your opinions to yourself. KT. Oh, that's not 19 point. That's 19,000. And then there's the point 3. Okay, this should be a comma, not a period. Newton per meter, Newton meter per radian. Let's get rid of Newton meter. I got a feeling this is going to come out in terms of radians, so you're going to have to convert that 2 degrees somewhere along the line. Yeah. Right here it is. You multiply it by pi, pi over 180, because that's pi radians per 180 degrees. And that's going to give you 0.0349. And that's radians, which is really not a unit, but you know what it means. You know what I mean. You know what this is supposed to be. Okay, and then this is over the square root of 1 minus omega over omega n squared plus 2. You've got your zeta 0.336 omega over omega n all squared. Alright, so you have, I didn't put the omega n in, but it's right here. So you can plug that in too. Then the only unknown you have left in this whole equation is omega itself. So then you just solve for that, and that will give you omega equals Okay, it says something about there being a negative root, and to ignore that. Okay, you're gonna get a plus or minus somewhere down the line when you're solving for omega over omega n, which makes sense because you got all these square roots and stuff. You're gonna assume plus, I guess if you, yeah, because if you do minus, it's gonna give you a negative number, and a ratio should not, really shouldn't be negative. It could be, but that's not really the value we're interested in. So if you ever get a plus or minus possibility, assume it's plus. Oh, that's what it is. I see it's I actually had to do the whatchamacallit equation. The high you know, opposite of, no, wait, no. Opposite of b plus or minus square root b squared minus 4ac all over 2a. Forgot what that formula is called. Anyways, you know what that one. Yeah, that one. And that can give you omega over omega n squared. Then you take the square root of that, and that will give you 64.16 radians per second. I know I am skipping a lot of the math here, but the important thing is that I want to see what equations we need to use and which ones are going to be important on the exam. So this is part A. This is the answer for part A. So let's go ahead and stop here and find the equations that are going to be important to have on the exam and to understand. Well, definitely torsional K is going to be important. Amplitude and how it relates with torsion is going to be important. Same thing with critical damping. You're going to need to know what it's like normally and what it's like with torsional system. And of course the ever important zeta damping factor, but that one's so easy. Well, this is actually two different things that I squared in here. This is actually omega n. The function of omega n is as ever important. But y'all should have this more or less memorized. It's probably a good idea to make sure you consider how it applies to torsion. Make sure that's on your sheet somewhere.